So today we are presenting visualizing sorting algorithms. What is sorting? Sorting means arranging numbers in order. In computer science specifically, sorting means arranging number in an array in ascending or descending order. Here we have an example of an unsorted array, which is 3, 1, 4, 2. And here's its sorted part, which is in ascending order. Why is sorting important? Sorting helps organize data and search faster. There is a method which is called binary search, which also requires sorting. There are many types of sorting algorithm. In this presentation, we are going to talk about 3 types of sorting algorithm, which are bubble sort, insertion sort, and merge sort. Objective of bubble sort. Our objective is to understand how bubble sort works and learn to compare and swap adjacent elements, and to observe how sorting progresses step by step and understand its performance limitations. Bubble sort. Bubble sort is a type of algorithm which compares two consecutive elements and check repeatedly. If they fulfill the condition, they are swapped. And after one complete iteration in the array, if the sorting is done in ascending order, the largest element gets bubbled to the end of the array. How bubble sort works? It compares each pair of adjacent elements and swap them if they are in the wrong order, and repeat this process until the list is sorted. Each full pass moves the next largest value to the end. Here we have a visual example in which you can see we have an array of 4 elements. In the first pass, it will compare 4 and 3. We have to arrange this array in the ascending order. So the condition will be if the first element of the array is greater than the second. So the swap will happen. So in first pass, the compiler or the program will compare 4 and 3. If 4 is greater than 3, which is true, then swap will happen. And then 4 is compared with 2, then 1, which you can see in the first pass. So the 4 is getting bubbled to the large because 4 is the largest element in the array. So in the second pass, you can see now 4 is in its right position. Now 3 is the largest element which is unsorted. So 3 will be get compared to each element. First 3 will be get compared to 2, then 1. So 3 will be bubbled to the second last element because 3 is the second largest element. Now same will happen till the array is sorted. In the first snippet, you can see we are asking user to enter the length of array, then declaring the array. Then a loop is executed, which will ask user to enter element and then store it on the correct position, on the correct index. Then in the second snippet, you can see we are asking user to select whether he or she wants to arrange the array in ascending or descending order. Now in this snippet, you can see this is the main logic. The outermost loop is for the printing of original array, and the inner loop, which is initialized by 0, and it will run till the length -1 -i. After every iteration, it will decrease by 1. Time and space complexity. In best case, which is when the array is sorted or partially sorted, and the average and worst case is the same, due to which that's why we don't use bubble sort in real life. Use case. What is the use case of bubble sort? It works well for a small or nearly sorted list, and it's great for teaching sorting basics. Now it is replaced by faster algorithms in real applications like merge sort, quick sort, and other. Here we have a video in which you can get a better understanding of how bubble sort works and how elements are sorted. Now, in conclusion, bubble sort is easy to understand and implement. It helps beginners visualize how sorting happens step by step. It is inefficient for larger datasets, but it's built foundation for learning advanced sorting techniques. Now Ammar will explain insertion sort.
Insertion sort. In this specific algorithm, we begin from the far left element, which is considered to already be sorted. Then we start comparing it with the neighboring elements, and if it's bigger, then a swap up happens with that element. Okay, moving on. The objective is to understand how insertion sort works and learning to compare and insert elements step by step and observe the sorting process visually. Now to understand how the actual insertion sort works. We start with the second element, assuming that the first element is already sorted, and compares the current element with each element in the sorted portion from right to left. And if the element is larger, it moves it to the right to make space and inserts the current element into its correct position. And the process goes on until the whole list is sorted. Now here we have a visual example. We will take an array of length 4, which is in its initial state as 9, 5, 3, 1. So we will consider 5 as the first element, and because 9 is already considered to be sorted, and 5 will swap with 9, and because 9 is obviously larger than 5. So then after that we'll consider 3 as the next element, and a swap will happen between 3 and 9, and and also 3 will also come before or 5. Now finally we will consider the last element, which is 1, which will be pushed to the far left of the array. So the final sorted array will be 1, 3, 5, and 9. So just this is the general overview of the code. We will declare and the arrays and variables, input the size of the array and the elements. The loop will start from the second element, and then it will compare and shift the larger elements to the right, insert the current element in the right position, and the process goes on until the array is sorted. So time and space complexity. So the best case is when the array is already sorted or close to being sorted, and the worst case will be when it is sorted in reverse. That's the worst case scenario. Moving on. Now to conclude this, I would say that insertion sort is easy to implement, and it is good for teaching the sorting fundamentals. It is efficient for small or nearly sorted elements, but it is not as good as merge sort or any like quick sort. So here is a visual representation on how it actually works. So that's all for insertion sort. Now I would like to call Ali for explaining merge sort.
Now we will talk about merge sort, and it is a type of divide and conquer algorithm. So it is done in the following manner. It is split the arrays into smaller arrays, and it keeps splitting until only one element is left in the array, and it then start merging them back in the sorted manner. And here's a visual example. So this is an unsorted array. It will first break down, start breaking them down into half of the arrays. So as you can see, these two halves get break down, and these two halves get break down until one element is left in an array, and then these will start uh, merging in a sorted manner. And first, we will compare 4 and 2 since 2 is smaller than 4. So 2 will come before and 4 will come after. And on this side, it is already sorted with 0 and 6 like that. And then we will compare 2 with 0. And since 0 is smaller, so we will store the smaller number first. And then we will compare 6 with 2. Since 2 is smaller, so 2 will all come here. Then 4 will be compared with 0. And since 4 is smaller, so it will be then stored. And then the last element would be stored in the last place of the array. Now, this algorithm employs recursion. Recursion is not a phenomena. It's a concept that when a function calls itself, and its working is a bit similar to while loop, since while runs on a condition, and if the condition is true, it keeps running, and when the condition becomes false, it stops, it terminates. So it is a bit similar to that, not exactly like that. So in the function, first we check our condition. If the condition is true, the function calls itself with the new data, and this is known as the general case where the function keeps calling itself. Now, if the function keep on calling itself, it will be useless to us. So we need an ending point where it breaks, and the function exits, it starts exiting. Actually, it's called unwinding. First, when it is calling itself, it's called winding, and then when the base case is reached, the base case is when when the condition becomes false, and the base case is reached. So then the function stops calling itself. That's called reaching the base case. So then we start unwinding. So here, first, we will talk about how we split the arrays. And here I have given the code that there's a function which takes the arrays as an input, and in P, it refers to the first address of the array, and R, it refers to the last element of the array. And first, we will see if the first element is lesser than the last element. So if it is not, uh, so it means that there is only one element in the array. When if P is 0 and R is 0, so there is only one element in the array, so it doesn't need to be sorted. It is already sorted. So that is the condition for the base case. And if it is not, then it will come inside, and it will calculate the middle value for where to break the array, and then it will call itself with the new updated values. And here is a function. Here's a function call for merging the subarrays. So here's a small example given of a 4-element array. So the middle would become 2. So the left, if you can see here, we call this the left array and the right array. And for this array, this would be the left array and this would be the right array. So here the left is referring to the first breakage of the array. So that's how we start to split the arrays. Now coming back to recursion, because it's a difficult concept to grasp. So if we imagine recursion like a tree, so let's suppose we have an array of 3 elements with the values 3, 2, 1. Now here is our code. I have inputted the values 3, 2, 1, and then first it will calculate the Q part. As you can see, the first P would be 0 in C language. Arrays are 0 in text, and R would be 2. So 0 plus 2 would be 2. 2 divided by 2 would be 1. So it will know that first the left part should start from 0 and go to 1, and then next part would be from 1 to 2. Not actually 1 from to 2, only 2. So when we have come inside this, and it says since 0 is still less than 1, so the function will call itself and divide the arrays again. And in the new array, it will be from 0 to 0 and 1 to 1, and the left array and the right array. And in the left array there will be 2, and the right there will be 1. In the left there will be 3, and in the right there will be 2. And we will merge them back into the our original array. So these two will come as merged, and now these two would be merged with this array. This was also divided at the first stage, just as I told you that it would start from 2 and go till 2, and then it would be compared from 1 would be compared with 2, and since 1 is smaller than 2, so in the original array we will store for 1 first and then the rest of the array. So if you try to visualize it as a tree, so first we have come into the function body with divide array, and since it is fulfilling the condition 0 is less than 2, so it will call itself, and then it is still fulfilling the condition 0 is less than 1, so it will call itself. But now here the base case is reached, 0 is not less than 0, so it will not further call itself, and 1 is not less than 1, so it will not call itself. So this is the part where these two are referring to, and then these two arrays are getting merged here. So 3 and 2 would get sorted. So and then of the first call where this array was divided, that this divide array is referring to that, and since 2 is not less than 2, so it will break itself here, and then it will merged 2, 3, and 1. So that's how we will get to the sorted array. Now this is the merging algorithm, the not the complete algorithm, but just the gist of it, how we are comparing it. So just like I told you here, that it will first compare, let's get to this example. It will first compare the address, the element at this address with the element at this address and store it here. And then when these two part are on the final stage, so the element on this address would get compared to the element on this address. We will have two separate pointers. This is I have indicated here. I is equal to 0, j is equal to 0. I for the left array, j for the right array. And we will start to merge them. If the element at I is lesser than the element at j, so it will be the first element to go into the actual array. And the sub-arrays are actually new arrays, and then the sorting is done in the original array. So it will continue until it is completely sorted. Now this is our code example. Here I have inputted 4 numbers, 100, 75, 50, and 25. So there are 4 elements, and so it will get divided into 2 parts. So first it divided 175. Now this could also be further divided. So 175 would be divided separately, but these cannot be further divided. So here the base case is reached. So 75 and 100 would got sorted, but 50 and 25 are remaining. And they will be called at the same stage, but at the the code level, it is not done simultaneously. And this goes in until the first 2 elements are sorted. So we will see in the example video shortly after. And just like that, 50 and 25 would get sorted, and then these two would start, and these are the 2 different arrays. And then 25 would be compared with 75. It is less than 25, 75, sorry. So 25 will come first, then 50, then 75, then 100. So it will then take us to the sorted array. Now here is the video, so you could get a clear grasp of the concept. Now, as to the efficiency, to compare the efficiency with the other algorithms, this is just for reference, efficiency graph of Big O. The Big O notation we use to check the efficiency of any algorithm. So O log n or O1, as you know, are the best, and the ON is also acceptable. But this merge sort is of O n log n, so it is a fair or better than in the bubble sort and insertion sort they were O n square, so they were horrible. And this just talks about the efficiency because keeps halving the arrays, so that's why log n. But since it touches all the numbers, so n comparisons are necessary. The total steps would be n log n. So it is faster for the bigger arrays than the selection sort or bubble sort or insertion sort. Now, just to summarize things up, the merge sort starts splitting the arrays first, and so once it reaches the one element array, then it just starts sorting and merging them back into sub arrays until in the final array, and it is efficient for large arrays. And the visualization part, although the code is not included in the presentation, but it is just for visualizing. There are many print statements, as you can see in our code, like here. So none of this was needed, and it would have just sorted the array, but it is for just visualizing to help beginners understand the concept, and computers follow. Okay, that's all for today. Hope you understand things a bit clearly than before, and we would recommend you check out our GitHub repository. We have done the complete posted the complete code there, so make sure to check it out.